Equilibrium describes the state that a system will reach if you wait long enough. So most reactions in chemistry reach equilibrium in times of ranging fractions of a second to many minutes. So kapag meron tayong equilibrium reaction, this is characterized by ito, the double arrow. The forward reaction, this one. So the A and B species will be converted into C and D products. So this one is backward reaction naman. So pwede ma-convert back si C and D into A and B. Okay. So in a chemical reaction, equilibrium is the state in which both the reactants and the product are present in concentration in which we have no further tendency to change with time. So there is no observable changes in the properties of a system. Kumbaga balance na wala nang reaction converting A to C, A, B to C and D, or C to D and A to B. So pag naano na yun, that state is now in equilibrium. So kapag meron kang ganitong reaction, this is characterized by a constant. So pag na-equilibrium, meron kang constant known as the equilibrium constant. So this means that the K equilibrium equals the molar concentrations of C times or raised to the coefficients. Yun. So ito mga to, concentration. If in aqueous solution. So where the small superscript letters denote the stoichiometric coefficients, and each capital letter stands for the chemical species. So ito yung mga species na present sa reactant. Ito naman yung mga coefficients nila. I-raise mo sila if you are writing the equilibrium expression. So the symbol A stands for the concentration of A relative to its standard state. Yeah? For solutes, the standard state is 1 molar. So this means that concentration of A divided by 1 molar. For gases, the standard state is 1 bar. For example, if D is a gas, the unit of concentration is in bar, divided by 1 bar. For solids, standard states are pure solid or pure liquid. So, if C is a liquid or a solid, ito yung dinedenote niya dun sa equilibrium expression. So, it would be unity. So, for solids and liquid, hindi natin sila incorporate dun sa equilibrium expression kasi equals to 1 lang din yung nila, concentration or standard state. Okay? So, to evaluate the equilibrium constant, the concentration of solutes should be expressed as most moles per liter or molarity. The concentration of gases should be expressed in bars, and the concentration of pure solids, pure liquids, and solvents are omitted because equals to 1 lang din or unity. So, let's have an example. Yeah. Right? The equilibrium constant for the reaction. So, paano natin gagawin yung equilibrium or incorporate yung species dun sa equilibrium constant ng reaction na to? So, first, yan. Naka-concentration yung mga, so itong mga to ilalagay natin. Yan. Pag solid or liquid, hindi natin sila ilalagay sa equilibrium. So, K is equal to Yung mga naka-aqueous is in terms of concentration, zinc 2 plus. So products sa taas, products, tapos reactant sa denominator. Okay? So we have H2 and then ammonia. Meron siyang coefficient, so that's squared. Divided by, okay. Divided by NH4 squared. So, ayan yung equilibrium expression or equilibrium constant ng equation nito. So, to denote na si H2 is gas, pwede natin siyang isulat as pH2, meaning naka-pressure siya. Okay, kasi yung unit naman niya is bar, so that's pressure, and then mga solutes natin is concentration, H4 plus 3. Ayan. So, nasurutan guys. Okay.
Sample pa yun.
Example. So, how about this one? This reaction is called the autoionization of water. Meron siyang values. Okay, so ayan. So for water, the ano is Kw, meaning this is your water. The equilibrium constant of water. So constant siya, depende on the temperature. At 25 degrees Celsius or at room temp, Kw is equal to 1 times 10 raised to negative 14. Since constant, wala siyang, hindi natin incorporate yung unit. Ano yung formula ng Kw? We have H plus and H minus. Yan lang. Ilalagay ba natin si water? Meron ba siyang denominator? Hindi. Kasi liquid siya. Yeah. So, ayan na. Yan na yung equilibrium expression ng water or the autoionization of water. So, another example. How about this one? Okay. So, this one is for ammonia. So, kapag for ammonia, yun, forward reaction yung poly natin. So, ano yung reaction? Meron din siyang value at 25 degrees Celsius. K of ammonia is 1.8 times 10 raised to negative 5. Okay, so let's write. This is for ammonia, so it is ano yung forward reaction. NH4, and then OH, and then the denominator is ammonia. And then, how about your ammonium ion? A of ammonium. You know? So, babaliktad. NH3, and then we have OH minus, and then NH4. Tama? Tama ba? Naintindihan niyo guys yung forward and reverse reaction pagkuha ng equilibrium constant.
Yes, ma'am.
Yes, ma'am.
Okay. So, pwede natin i-manipulate yung equilibrium constant. So, consider the reaction. Meron tayo H plus, and then A minus. Yung KA, KHA, A is H plus and A minus over HA. So, for the reverse naman, we have H plus, A minus, HA. So, ito naman, equilibrium niya, i-ano natin as K prime. So, HA over H plus times the concentration of A minus. So, actually, makita yun, binaliktad na, di ba? So, yeah. Ijay denominator dito, K is the numerator of the K prime. And the numerator of the K is the denominator of a K prime. So, K is equal to, ano relationship na? Ano kayong relationship nila? K is actually the reciprocal of the K prime. We have this reaction H2O H plus OH minus and then NH3 NH4 plus OH minus. Ano daw yung equilibrium reaction ng NH4 and then H plus NH3. Phase. Base kan detoy dua na reaction. So kanina nakuha natin yung KW which is your OH and H plus. And ano yung K ammonia? Guys?
NH4 plus.
NH4
NH4 plus
tapos OH negative lang. Over NH3 po.
Wow, nagalis to. Pa? Okay. So, timasapol tayo is NH4. Nandito siya sa reactant. So, kailanganin natin yung reverse nito, which is nakuha natin kanina. NH4. So, reverse lang natin. NH3. Okay. NH4 plus and then OH minus. Okay? So, i-reverse natin ito. Para makuha natin yung KW ng reaction na to. So, NH4 plus H2O, OH minus rather. OH minus, tapos NH3 plus water. So, pag ganyan, kunin natin yung net reaction, check natin if ito yung reaction na yun. So, ano yung gagawin natin? Kapag yung isang reaction, nakita mo na merong same dun sa product and nasa reactant siya, ka-cancel out natin. Okay? Ano pa iti agpada? Tinga bali cancel out.
OH minus.
OH negative.
Okay. OH negative. So, kunin natin yung net reaction. Dito sa right side, we have NH4. And dito sa product, we have H plus and then NH3. Yeah? So, that is actually equal to KW times KNH4. Yeah? So, check natin. KW is OH minus tapos H plus times NH3 and then NH4 and then OH minus. So, naka-numerator to, magka-cancel sila. So, yung natira na lang, KNH4 plus is equal to NH3, H plus, and then NH4. So, tama ba? Kunin natin yung NH4 dito. H plus, NH3, and then NH4 plus. Makakata nyo guys? Sorry, nagwarat isurat ko.
Yes, ma'am.
Okay. So, ano't value ni KNH4 garot? So, kanina, meron tayong KW that is 1 times 10 raised to negative 14. And then K ni ammonia is 1 times 10 raised to negative 8. Ay, sorry. 1.8 times 10 raised to negative 5. Ano't value ni KNH4 na rod? Can you compute? Take note your relationship ni ano dito? This one and this one. Kumbaga, is ano siya, reciprocal. KNH3 is equal to 1 over KNH4. For this this reaction. Is equal to KW yan, times 1 over KNH3. Na? So, 1 times 10 raised to negative 14 times 1 divided by 1.8 times 10 raised to negative 5.
5.5 times 10
Raised to
to raise to negative 10.
Is to negative 10. So, ganyan kumuha ng equilibrium constant values. Okay? So, kung given ka lang ng dalawang equilibrium constant na values, pwede mong i-manipulate yung equilibrium constant to get another equilibrium constant of another species present sa reaction. Ayan. So, calculate, find the K for the reaction. CU plus H and plus H plus. Ano yung gagawin natin? Ano yung K for this one, for this reaction? So, given tayo ng dalawang equilibrium reactions, meron din tayong values ng K. Ano yung papalitan natin or ano natin sa backward reaction? Is it reaction 1 or reaction 2? So, tignan nyo kung nasaan yung So, baliktarin tayo nga dua. Ayan, mensa lang ti baliktarin tayo. So, baliktarin tayo nga dua. Same itong lang. Sa akin nga to, or number 1 or number 2, yung i-reverse natin.
Number 1, no?
Okay, tama. Pag reverse natin tong number 1, this becomes K prime. which is equal to 1 over 4.9 times 10 raised to negative 9. Paki-compute. Okay, so copper.
Two point zero four times 10 raised to negative 10, ma'am.
Negative 10. Okay, so yan yung value ng K prime. Okay, so nati-cancel tayo dito eh. Ito sa dalawang, so ito na yung K prime and A. So 2.04 times 10 raised to negative 10 and then this one is 2.2 times 10 raised to negative 5. Nati-cancel tayo.
And 3 negative.
Okay. Yan, 3 negative. So, tignan natin if same yung makukuha nating reaction dito sa required. So, we have copper plus and then copper nitride plus H plus. Okay? So, para makuha yung K dito, we have K times K prime. Pag-multiply, ang pag-add. Okay? So we have 2.04 times 10 raised to negative 10 times 2.2 times 10 raised to negative 5. Ano yung answer? Tama ba yung nakuha natin dun sa K prime? 1 divided by, that's 1 divided by 4.9 times 10 raised to negative 9. So, nung pangato tayo, agbarin nga positive dapat, TJ. Ano na? Exponent na. Paki-recompute man, guys. Ano't na ala yun? Again, ni K prime. Is equal to 1 divided by 4.9.
2.04 times 10 raised to
0.04 times 10 raised
10 raised to negative 10 talaga.
raised to 8, ma'am.
Raised to 8, ma'am.
Raised to 8, ma'am.
Raised to 8 po, ma'am.
Tapay sa bari. Di maalagkit. 204081632.
0.7. Di last niya, ma'am.
Isa't na alak. Api sa balit na alayo. Ano input yung ita, calculator yun. Input is 1 divided by 4.9 times 10 raised to negative 9.
That's more positive pa.
Isa't na,
Yes, ma'am. Sumot niya.
Digit 2.04?
Yes, ma'am.
yes, ma'am.
Isumot lang
Ma'am,
na isa dito lang kasi
naka-scientific
agad das
notation.
agparait mo DJ decimal point lang to, ma'am.
In scientific notation, may namin, ma'am.
Guys, kurang awan negative yo. Guys, awan negative yo. Dito na alam eh. Kita? Dito. Walang negative yung in-input nyo. So nga tinaala yo is nabababa. No, i-divide kayo ti negative no exponent. Umatano ka di value no. Ayan, so yan. Walang negative. Kan yung negative digit 10 can 9. Dumakyan no kadbali. I-try you guys. Can you see? Tala yun?
Yes, ma'am.
Yes, ma'am.
Ayan.
Sabsabali.
Ayun. So, panilip-lipatan DJ. Tigitig values tayo is very small da. Very small. So, negative sila. Negative yung exponent. That's like 0.0000. Mga 8 na 0. Yan. So, very small. So, pag divide natin yung maliit na number, lalaki siya. yung value. Kukunin natin yung reciprocal niya, makakakuha tayo ng malaking value. Okay? So, this is 204081632.7. So, i-calculate natin.
Ma'am, damag lang. Madi
Yes.
nga
Mga is
2.04 times 10 raised to negative 8 data, ma'am. Or okay lang po.
2.0.
Positive 8 san.
Ma'am, mga is mga is ito.
1, 2, 3, 4, 5, 6, 7, 8. Oh, ayan. Ano't maala yung haraga value?
2.04 times 10 raised
times 10 raised to 8.
10 raised to 8 lang, ma'am.
Yeah?
times 10
Times 10
raised to
raised to 8.
positive 8.
2.04 times 10 positive 8, ma'am. Hanga negative. Kasi to the left, di ba, ma'am? Pwede, ma'am.
When. Times 2.2 times 10 raised to negative 2.2 times 10 raised to negative 5. So, ano di dyan unknown niya kay tayo? We have, yung kinukuha natin kay value is multiply 4, 8, 9.8. So that's the exponent 4.5 times 10 raised to 1, 2, 3. Positive 3. Oh, naala? Intindihan, guys?
Yes,
Yes,
ma'am.
ma'am.
Okay, so another example. Sulat niyo pa lang, tapos, so we have A plus AG plus CL minus and then AG, CL, which is sample. Okay, is 2.0 times 10 is negative 3. Second reaction, CL, AG, CL2, negative. And then AG, CL, AG plus CL minus C solid. Okay, is 1.8 times 10 raised to negative 10. So the unknown, find the K for the reaction AgCl and then AgCl aqueous. So paano natin gagawin yan? Paano natin gagawin? Ano natin, baliktad din tayo. Or maalatay ba agadin? Makuha na ba natin kaagad? Ano yung gagamitin nating reactions? Maalatay agadin eh. Oh, lagyan natin ng label. 1, 2, 3. Ano yung gagamitin nating reactions? Na dalawa.
Reactants yung number 3 con G. Product yung number 1, ma'am.
Okay, so gagamitin lang natin for this is equation 1 and equation 3. Babaliktarin ba natin or hindi na? Meron ba tayong babaliktarin or wala?
Wala, ma'am.
Oh. Okay, so we have Ag plus Cl minus AgCl aqueous, HgCl solid, forming your so cancel, and then we get the reaction. Okay, so K nito is 2 times 10 raised to negative 3. This one is 1.8 times 10 raised to negative 10. Denote natin as K1, K3. And this one is K4 kasi ito yung K2. Tapos K4 yung unknown. Paano natin kukunin yung K4? Multiply natin yung K1 and K3. So, yun. Ano yung value?
3.6 times 10 raised to negative 13, ma'am.
3.6 times 10 raised to negative 30. So, naalala guys?
Yes, ma'am.
Yes, ma'am.
Yan. Another problem. Find the K or KgCl2 negative and then HgCl S plus. Yan. So we have the unknown is AgCl2 negative and then AgCl plus chlorine ion. So, obrahan tayo is baliktad din tayo amin. I-reverse tayo amin yung given na reaction. We have the first reaction or tamnol alis to yung siya gamin ket ag start na kendeti reactant. Iji reaction niya adateti reactant mo. Tumal alis sityo burak no kwa. So, since deti nga reaction is at the ijay reaction 2. So, at danit reactant, so baliktad din tayo ni reaction 2. Okay? And then, AgCl aqueous plus chlorine ion. So, since binaliktad tayo dito, the K becomes 1 over 93. Masarutan? Guys? And then next is, saan natin makikita to? AgCl solid. Tapos nasa product siya. So, dun sa given reaction, nandito siya. Diba? Pero nasa reactant, so babalik ta rin natin yung equation number 3. So, we have Ag plus Cl minus, and then we have AgCl S. Yan. And babalik ta rin din natin yung K niya. K3 prime, this is K2 prime, 1 over 1.8 times 10 raised to negative 10. And then next is yan. Saan natin yung makukuha? Actually dito. Pero, yan natin dito gamin makancel. Ijay. Tino-connect reaction man get AgCl minus Ag plus, and then we have AgCl, and then AgCl S. So, di masabol tayo is AgCl2, AgCls can chlorine. Nya? So, ikatin tayo dito eh. So, we have ikatin tayo detoy can detoy. Pangkitan tayo. Adajay equation 1. Nya? This one. So, ni AgCl is adat reactant. Ket dito, adan na met reactant. So, baliktad din tayo ni equation 1. Becomes AgCl, tapos Ag plus Cl minus. So, then, cancel, 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 cancel. So, this one is K1 prime, 1 times 10, 1, negative 3. So, the remaining, we get now the unknown reaction plus chlorine. So, to get the K5, we multiply K3, K2, and K1. So, 1 over 93 times 1 over 1.8 times 10 raised to 10. So, tinobrayo, guys. 2.0 times 10 raised to negative 3. Not maala. Can you compute?
2.99 raised times 10 raised to 10, ma'am.
Yes, equals 2.99 times 10 raised to 10. So, ayan, yung equilibrium natin and equilibrium constant. Okay? So, let's go to your H plus ion. Kapag sinabing hydrogen ion, that's your H plus ion. And then, ano yung implication niya to your acids and bases. So, in aqueous solutions, especially in biological systems or in systems ng body natin, the concentration of H plus ions is very important. So, biological systems often take great pains to make sure that their hydrogen ion concentration, represented as, or by the measurement of pH, which is the measurement of acidity in a solution, doesn't change. No? Kasi pag nag-change yan, it can result to death. So, even minor changes in hydrogen ion concentration can have dire consequences to a living organism. So, for example, in human blood, only a very small range of hydrogen ion allows to function properly. So, the pH ng blood is nasa range na 7.35, 7.40, 7.35. The pH range is 7.35 to 7.45. So, yan yun. So, 7.4 is the physiological pH. So, kapag bumaba lang daw ng konti lang, yun, magkakaroon na ng drastic effect. Magkakasakit na tayo kapag nagbago yung pH ng human blood. Either bumaba or tumaas dito sa range na to. Yeah? So, because living organisms are so dependent on pH, we review the concepts of acids, bases, and pH in the following section. So, in equilibrium, so ito yung ng water, autoprotolysis or the auto-ionization of water. No? Okay. So, ano ulit ti pH ni water at normal conditions? Yung pina-exam ko sa inyo nung first meeting natin. Ano yung pH ng water?
7, ma'am.
7, ma'am.
Okay. pH ng water is 7. This is neutral. No? Neutral, yung solution kapag the concentration of H plus is equal to the concentration of OH minus. Yeah? Kapag mas mataas yung concentration ng H plus kesa dun sa OH minus, the solution is acidic. No? Kapag mataas yung concentration ng H plus. Kapag naman kabaliktaran, kapag mas mataas yung OH minus, the solution is basic. So So, yung mga acidic solutions such as your lemon juice, yung lemon pH niya is nasa 2. So, yung mga lemon, vinegar, ano yung taste nila, di ba? They are sour. Tapos yung mga ano naman, mga bases, yung ampalaya, they taste bitter. So, the equilibrium of hydrogen ion is present in all aqueous solution. So, water may or may not be the major hydrogen ion source. So, usually, it's not the major hydrogen source kasi tignan niyo lang yung concentration ng hydrogen. At pH 7, the concentration of hydrogen is equal to the concentration of OH, which is equal to 1 times 10 raised to negative 7, which is very small, no? So, usually, hindi siya ang source ng H plus or magdedetermine ng pH ng solution. Magdedetermine ng pH ng solution is your acids and bases. No? So, ito yung autoionization ng water. Either ganyan or ito, H2O H2O H3O plus OH minus. So, ito ang tawag dito is your hydronium ion. Same lang sila ng H plus. Okay? Meron tayong kulang. Dapat dalawang water para ma-balance yung reaction. Ayan. Okay? So, the double arrow indicates that this reaction is in equilibrium. As such, there must be an associated equilibrium constant. Kasi kaya yung kinawa natin kanina. The equilibrium constant in the preceding equation is Kw. So, the Kw is the product of the concentrations of the hydrogen ion and your hydroxide ion. So, the OH is called hydroxide ion. Constant siya at 25 degrees na 1 times 10 raised to negative 14. Sa body natin, ano yung normal body temperature? Natin?
37 degrees.
Okay, tama. So, sa body natin, mag-iiba yung value ng Kw. So, we have 2.4 times 10 raised to negative 14. Tumaas ba or bumaba? Bumaba, di ba? Ayan. So, in pure water, actually, the pure water at 25 degrees, H plus, Dg nga to, Dg plus, is equal to 1 times 10 raised to negative 7 molar. So, at the normal body temperature, bumaba ulit, naging 1.6. So, the same, at 25 degrees Celsius, the same yung concentration ng H plus and OH because they're formed in equal amounts during the autoionization reaction. So keep in mind that H plus is equal to OH minus only in pure water. Tapos pag bracket sila, meaning that the concentration and the unit of concentration that we use is molarity. Okay? So kaya nakuha yung value ng Kw at 25 degrees na 1 times 10 raised to negative 14. Kasi di ba sinabi dito at 25 degrees, the value is 1 times 10 raised to negative 7 for H plus, and which is equal to OH minus, which is equal to 1 times 10 raised to negative 14. So yan yung value ng Kw, kung paano siya na-derive. Okay? So, actually, hindi convenient yung puro exponent, no? So, or the exponential form. So, usually, we have a simplified way, which is the pH. So, the pH, the formula is the negative log of the concentration of your hydrogen ions. Ganyan. Yeah. So example, we have negative log of 1 times 10 raised to negative 7. Ano yung value? Ano yung value, guys?
Seven, ma'am.
So, yan. So, kaya din, the pH of water or pure water at 25 degrees is equal to 7. Kasi na-derive yan from the formula of the pH, which is equal to the negative log of 1 times 10 raised to 7, negative 7, which is equal to 7, which is a neutral pH. Okay? Ayan. So, meron tayong for acids and bases, meron tayong tinatawag strength of acids and bases. So, they are classified as strong or weak depending on whether they react completely or partly to produce H plus or OH minus. So, because there is a continuous range for partial reaction, there is no sharp distinction between the weak and the strong. However, some compounds react so completely that they are unquestionably strong acids or bases, and everything else is defined as weak. So, example, kita yung dito picture. So, kapag sinabing strong acid, they are ionized completely in a water. So, nako-convert lahat sila into ions. For example, we have your HCl, which is a strong acid. Nadi-dissociate siya completely into H plus and Cl minus. So, at equilibrium, wala ng HCl kasi na-convert na siya lahat into H plus and Cl minus. Yan. So, with the weak acid, ito naman yung weak acid mo. So, example is your HF. Si HF, at equilibrium, konti lang, partly ionized. Yeah? So, at equilibrium, meron ka paling natirang HF. Yan. Tapos, konti lang yung na-ionize na N2H and fluoride negative or the fluoride ion. So, ganyan yung definition ng strong acids and weak acids. Same as true din sa strong bases and weak bases. Ganyan din. At equilibrium, yung strong bases, ma-ionize sila completely. And yung weak bases, konti lang, partly ionized. Okay? So, paano mo na-determine if an acid is strong or base? So, meron tayong common strong acids. We use the mnemonics and BCC, and CSI. CSI and BCC. So, una is your HCl. Pangalawa is your H2SO4, HI, HNO3, HBr, HClO4, and your HClO3. So, itong mga to, when they are acting in a solution, they produce 1 mole of H plus ion. So, kung ano yung concentration nila, yun na din yung concentration ng H plus. Okay? So, yung mga strong bases naman, so kung wala dito sa common strong acid, assume na, sila? Weak acid. Iba yung computation naman ng weak acid. Okay? Computation ng pH, medyo komplikado. So dito, madali lang. So for strong bases, we have lithium hydroxide na OH, KOH, RPOH, cesium hydroxide, R4, and this is a quaternary ammonium hydroxide, NH, and OH. So, ang mga to. Meron ding calcium hydroxide and barium hydroxide. And then we have CaOH2, and then ayun. So ito yung equilibrium reactions nila. For example, we have the principal components that make the rainfall acidic are nitric and sulfuric acids. So nandito sila, di ba? So ito si nitric and sulfuric acid. So they are strong acids. Each strong acid or strong base in aqueous solution dissociates completely to provide 1 mole of H plus or OH minus. Nitric acid is a strong acid, so the reaction O3. So, tignan nyo guys, isa lang yung single arrow lang, which means that na-dissociate sila completely. No? Ayan. So, ganyan yung reaction. So, nag-goes to completion. In regard naman to sulfuric acid, 1 proton is dissociated, H2SO4, H plus, and then HSO4 negative. Pero yung second na, ano lang niya, is uric acid na. No? So, we have H plus SO4 to negative. So, ganyan yung reaction ng ano. So, this is your sulfuric acid. This is your bisulfate. And this one naman is your sulfate ion. Okay? So, you have your nitric acid. And this is your nitrate. Okay? Ka nito is equal to 0.001. So, can you guys write the, hindi na. So, for example, compute tayo ng pH. Calculate the pH of 0.1 0.01 molar nitric acid. Simple lang. Just get the negative log of 0.01. And that answer.
Two, ma'am.
Two, ma'am.
So, tama. So, each niya is 2, meaning acidic. Yung solution na merong 0.01 molar na HNO3. And if you, the reaction, kung ilan yung HNO3 mo, since completely dissociated siya, yun na din yung concentration ng H plus mo. Okay, so 1:1 lang. No? So another example, calculate ayan. How about this one? Ano yung pH niya?
Two point 38, ma'am.
Okay.
38 po.
pH is negative log equals 2.38. So, ganyan lang yung pag-compute ng pH ng strong acids. Okay? So, before we go on to the computation of the strong bases, let's discuss muna, Tagalita. Let's discuss muna about this one. Let's answer muna dito. The answer ng letter A. Negative log
3,
3,
ma'am.
ma'am. 3. So, about letter B. Take note, naka-millimolar yon. So, the negative log, convert natin siya into molarity. So, 3.2 times 10 raised to negative 2 times 1 molar is millimolar. So, 1 times 10 raised to negative 3. Ayan. So, answer 3.2 times 10 raised to negative 1. Positive 3 raised to 1.
0.49485, ma'am.
0.49, ma'am.
Ito ba, data? Tapos, negative log 2 negative times 10 raised to 1, 1.05. Wait lang, 3.2 is negative 2 divided tapos, wrong. I mean, negative kaya. Doon. 3.2 times 10 raised to negative 5. Kasi negative 3 plus negative 2 is negative 5 molar. So, not pH? Not na-compute you?
4.49.
4.49.
4.49.
Okay, so this is 4.49. So, ganyan. Okay? Make sure that the concentration is in terms of molarity. Okay? So, ayan. So, kapag ganyan, guys, meron kayong concentration na naka 1.0, tapos times 10 raised to, agad-agad na yung kung ano yung exponent, yun na din yung pH. Okay? So, we have at 0 to 6, we have your acidic solution. pH equal to 7 is neutral. 8 to 14 is basic solution. Okay, so napansin nyo kung ano yung exponent kapag this is 1, no? Yun na din yung pH. So, hindi nyo na kailangan mag-compute pag ganon, given, no? And then, solutions with pH less than 7 are acidic, pag greater than 7, they are basic. Solutions whose pH are 7 are neutral. So, the pH of pure water is neutral, pero be careful though, not every solution that has a pH of 7 is pure water. For example, if you add table salt or asin to the water, the pH remains at 7, but the resulting solution is certainly not pure water. Ma'am, bakit po hindi nag-change yung pH? Kasi tignan nyo, H2O plus and then Cl, we have H plus OH minus plus Na plus Cl. Meron bang nadagdag na H plus dun sa solution? Well, yung salt dun sa dinagdag na salt dun sa pH ng solution. Kaya nag-remain yung pH ng solution at 7 kahit na nagdagdag ka ng salt. Kasi wala namang H plus dun sa salt. Okay? Naintindihan ba? So, the pH scale is open-ended, meaning that the solution can have pH greater than 40 or pwede ring mag-negative. For example, the pH of 1 times 10 raised to 1 solution of HCl is -1 kahit i-compute nyo pa yan. The 0 to 14 scale is a convenient part of the pH scale for most real-world solutions, especially ones found in biochem. So most biological systems have a pH near 7. Say malapit na physiological pH natin at 7.4. Although significant deviations may exist. For example, yung stomach natin has a pH close to 1. So very acidic yung stomach acids natin. That is close to 1. Ma'am, bakit hindi siya nadidissolve? Because of the composition ng stomach natin. Meron tayong lining that is capable of withstanding the low pH value of the stomach. Ayan. Madal niyo ba dito, Diana? So, to calculate naman pOH, which is the concentration of P. Ayan. Kapag meron kang P, yung sa that is negative log. Tapos, kung ano yung ng P, yung concentration, nilalagay mo. Okay? So, you can calculate the hydroxide ion concentration from the hydrogen ion concentration constant. Kasi di ba yung formula natin ng Kw is H plus and then OH minus. Kapag unknown yung OH minus, ano yung formula? Equals A divided by H plus. Tama? So, yan. So, kapag meron kang H plus, tapos, pinapakompute yung pOH, yan. Nakukuha mo siya using the Kw. Pero pOH yung unknown, so kapag nakuha mo na yung OH, yan mo na siya dun sa pOH, which is the negative log of concentration of OH negative. Or simply, kapag meron kang H plus, convert mo siya into pH, and then pag pOH yung unknown, 14 minus H lang is equal to pOH. So for example, if a solution has an H plus of 6.2 times 10 raised to -6, its pH and pOH would be, ano yung pH niya? I-compute?
Five point 20761.
5.21, ma'am.
5.21. Tapos, pOH natin is 14 minus pH. 14 minus 5.21 is equal to?
8.79, ma'am.
Okay. 8.79. Okay? So, example, let's calculate the pH of 1 times 10 raised to -2 molar. So, isulat natin, number 1, KOH, K plus OH minus. So, 1:1. So, this one is the concentration of your OH minus. Nya? 1 times 10 raised to -2 molar. The unknown is the pH. So, compute natin yung H plus. Ano gusto nyo? This one or the pOH na agad? Gamitin muna natin yun. 1 times 10 raised to -14 divided by 1 times 10 raised to -2. Answer is 1 times 10 raised to -12. Tama? So the
Yes,
pH
ma'am.
is equal to 12. Kapag naman ginamit natin yung pOH is equal to 1 tapos 2. So the pH is negative 2. pH is equal to 14 minus pOH. So 14 minus 2 equals 12. So pareho. Ana't man alis to kanyayo. Nagosar pOH, may nagosar DJKW.
POH.
UH po.
POH.
Okay, so depende kanya yun na anatial alis to. So how about number 2? So barium hydroxide, we have Ba plus and then OH negative. Balance ba? Correct na ba yung reaction natin?
No, ma'am.
No, ma'am.
Oh, anat wrong?
OH.
OH, ma'am.
Oh, anat ikabil tayo nga ro, tap no mabalance.
Tubay, vitamin.
OH.
Okay. Okay, so for every 1 mole of barium hydroxide, there is 2 moles of hydroxide ion. So, this is 7.7. Nakamillimole yon. So, convert na natin siya into molar. Yeah? So, this is your barium hydroxide. Ano nga rati concentration ni hydroxide? So, balik niya, multiply natin ng 2. Okay? Anong answer? Magets, naapa i-multiply tayo dito.
Yes, ma'am.
Okay, so ano nga rati value na? We have 0.154.
0154.
0100.
molar. Isurat tayo latang. Amin niya kadikado ti amin. Okay? So, alam tayo di pOH is equal to negative log of 0.0154 is equal to
1.81.
81. pH is 12.19.
12.19.
9.8.
Yeah.
19.
Okay, so yan. Masurutan yon kasunod agad at pH given the concentration of your strong acids. So dagito is strong acid niya. Okay. So hindi niyo siya madadiretso na makuha yung pH. Kailangan i-convert muna or kunin yung pOH then pH. Okay? So yan. Step tayo dyan. Okay. So, kapag naman given tayo ng pH, tapos unknown yung H plus and OH minus, yung gagawin lang natin is 10 raised to negative pH if H plus yung unknown and 10 raised to negative POH if OH yung unknown. So, for example, find the hydrogen ion concentration So unknown is H plus. In the solution, whose pH is, so ano the answer ni letter A? H plus is 10 raised to negative 4.44. Answer?
3.63 times 10 to the negative 5.
3.63 times 10 to the negative 5 molar. Okay? How about letter B? Take note, H plus yung unknown. So, kunin muna natin yung pH. 14 minus 2.32 is 11.
11.68.
Then, align tayo ni H plus, which is 10 raised to negative 11.68.
2.09 times 10 raised to negative 12, ma'am.
Okay, 2.09 times 10 raised to negative 12 molar. So, ganyan naman yung pabaliktad. Unknown yung H plus natin. Ayan, OH natin. Okay? So, ito, applying na tayo of the Bronsted-Lowry dito sa equilibrium ng acids and bases. So, because the acidity or the pH level of biological medium is very important, we take a look at the most accepted theories concerning acids and bases, which is the Bronsted-Lowry theory. Meron pang dalawang theory, we have your Lewis and Arrhenius. Pero dito sa biochem, yung ina-accept natin or pina-follow lang natin na theory is the Bronsted-Lowry. So according to this theory, acids are proton donors and bases are proton acceptors. So yung sinasabi nating proton is the H plus. So acids increase the hydrogen ion concentration of a solution. Tayo nakita natin kanina kasi di ba na dissociate sila into their ion. Example, we have your HCl, dissociates siya completely into H plus and Cl minus. So, dinagdagan niya ng H plus yung solution mo, kaya pinabaan nila yung pH. So, yung relationship pala ng concentration, kapag mataas yung concentration, bababa yung pH. No? Kapag mababa yung H plus, mataas yung pH. Yeah? So, kapag mataas yung H plus, they lower the pH, in other words. Some acids, known as strong acids, are very efficient at changing hydrogen ion concentration. So, they essentially completely ionize in water. Most acids, particularly the biologically important acids, aren't very efficient at generating hydrogen ions, so they only partially ionize in water. Kasi kapag strong acids yung mga nasa nasa body natin, yun, masyadong bababa yung pH natin. So kailangan, this biologically important acid only partially generate hydrogen ions para ma-generate yung or ma-maintain natin yung physiological pH natin sa body. They are known as acids. Okay? So bases react or accept rather donate hydrogen ions in a solution. Bases decrease the hydrogen ion concentration in solutions because they react or kinukuha nilang yung H plus kaya bumababa yung pH. Tumataas yung pH ko na. Bumababa yung H plus kaya kapag basic yung solution, mataas yung pH. Okay? So, strong bases, although they can accept hydrogen ions very well, are so important in biological systems. So, yung mga biologically important bases din are weak bases. Okay? So, the Bronsted-Lowry theory helps to explain the behavior of acids and bases with respect to equilibrium. A Bronsted-Lowry acid is a hydrogen plus donor, and a Bronsted-Lowry base is a hydrogen plus acceptor. Acetic acid, which is the weak acid found in vinegar, partly ionizes in the solution. So we have H3, COOH, plus water, forming your H3O plus CH3COO negative. Ayan. So, si acetic acid dito is the acid kasi nag-donate siya ng H plus niya. Naging acetate ion siya. No? Baliktad. So, dinonate niya yung H plus niya kay water. So, si water ngayon dito, since nag-accept siya ng hydrogen, ang ano ng water is a base. So, this is your acid. Okay? So, nag-accept niya. So, this water is a Bronsted Lowry base. So, if ano naman, babalik rin natin yung equation, i-reverse natin, the acetate ion then accepts yung isang hydrogen forming your acetic acid. So, the acetate ion becomes a base and the H3O plus or the hydronium ion is your acid. Magets you guys? Can you follow?
Yes, ma'am.
Okay. Okay, medyo. So, mas ma-follow you to later. Yeah? So, the double arrow indicates that the acetic acid, since it's a weak acid, is that it does not completely ionize. So, for a strong acid, complete ionization would occur as indicated by a single arrow. So, the equilibrium arrow, sa beta, indicates that all three chemical species are present in the solution. We have the acetic acid, COOH, the acetate ion, COO negative, and the hydrogen ion or your H3O plus. Okay, so along with the water solvent. So, in Bronsted-Lowry theory, you consider the acetate ion to be a base because it can accept hydrogen ion to become acetic acid. So, yun na nga. So, according to this theory, two substances differing only by one hydrogen, such as the acetic acid and the acetate ion, are members of a conjugate acid-base pair. Yeah, so tingnan nyo, this is your acetic acid and this is your acetate ion. So tipag difference sa anda is awan lang mesa nga hydrogen ni acetate. Kaya, so the species with the additional hydrogen is your conjugate acid. So this is your conjugate acid. And the species with one less hydrogen is your conjugate base. Kasi capable naman na siya mag-accept ng hydrogen if re-reverse natin yung reaction. So you can express the equilibrium from the acetate example by the mass action expression. So example, so we have CH3COOH plus H2O H3COO negative plus H3O plus. So, ano yung K-equilibrium? K-equilibrium. Can you guys, recite kung ano yung K-equilibrium? Ano yung nasa numerator? Alipatan niyo, Jimmy, ang muna nga topic na yun?
Dito, right, ma'am.
Okay. We have your concentration of the acetate ion as well as the hydronium ion divided by a denominator.
CH3COOH.
H3COH, ma'am.
Lang?
Yes, ma'am.
Okay, ang kahirapan ni water. So, ganyan. So, kapag, so ano si water dito? Ano yung conjugate? So, si water dito is a base, di ba? Kasi nag-accept siya ng hydrogen, no? So, mas madaming hydrogen CH3O plus na siya yung conjugate acid. Okay? Conjugate base. So, ito yung conjugate acid, ito yung conjugate base. Yeah? So, kapag hindi natin, yan, no, incorporate yung water, ito lang, H3COH, H plus, and CH3COO negative. Kaya yung sinasabi nila na pareho lang yung H plus and H3O plus, ano yung K-equilibrium? We have CH3COO negative, and then H plus, and then CH3COOH. So, same lang, di ba sila? Ito lang, pareho, kaya pareho, sinasabi na pareho yung hydronium ion and hydrogen ion. Okay? So, take note of that. So, since the acetic acid is an acid, so we denote pala this one as your Ka. No? So, denote that this equilibrium expression is for the acetic acid. At 25 degrees Celsius, the value is pareho ng Kb ng ammonia, which is 10 times, 1.8 times 10 raised to negative 5. Ayan. So the A subscript that this expression represents an acid. The square brackets represents the equilibrium concentrations of the species present. So, you can express Ka as pKa. So, meron ulit tayo yung P, which means that that's negative log. And yung kaabay na is na P and negative mo. Okay? So, ito yung general expression ng equilibrium expression or equilibrium constant ng acetic acid or weak acid. Okay? So, Ka is equal to H plus times the concentration of the conjugate base divided by the concentration of the conjugate acid. So kapag meron kayong reaction, determine nyo na agad yung sino yung conjugate base and sino yung conjugate acid. Tapos, i-plot nyo na dito sa equation kasi there are no variations allowed in this equation other than the actual formulas of the conjugate acid and base. So for example, write the acidization reaction of formic acid. HCO2H. So, nung nag-dissociate, anat products na guys? Ag-form T, H plus, then D. So, this is formic. Nagbalinso na nga, formate ion. Okay? So, sino ti conjugate base na ita, yung formic acid? Is it the H plus or the formate ion? Okay. So, basta ti Ana is meron silang difference ng 1 hydrogen. So, this is your conjugate acid. So, ito na yung conjugate base ni formic acid. Okay? So, dun sa general formula, we have H plus and then conjugate base and then conjugate acid. So, anong formula ti Ka? Can you guys recite? We have H plus and then sino dito?
HCO2.
CO2.
HCO2 negative, and then your formic acid.
CO.
Ayan. Okay? Naintindihan? The formula for the value of the formic acid is 1.8 times 10 raised to negative 4. Ayan. Value. Okay? So, like an acid, a base, that's a Kb value. So, meaning, the subscript meaning a base. So, a weak base like ammonia is part of the following equilibrium. Can you predict the product, guys? Ammonia is a base. So, accept na proton. So, ano't pagbalinan ni ammonia? Ha?
NH.
NA or positive. Pagbalin ng ammonium. Tapos ni water, since the TT conjugate acid mo, ni water dito will act as a base. Okay, sana pagbalinan ni water.
OH
Plus,
negative.
OH
okay.
negative.
OH negative. So, ganyan. So, yung conjugate base ng ammonia is your ammonium, and the conjugate, baliktad. sorry. Baliktad. Ammonia pala kasi is a weak acid, sorry. So, this is your conjugate base. Si water dito, nag-donate siya ng H+. So, acid siya dito. So, si water, tawag sa kanya is amphoteric kasi capable siya of being an acid or a base. Depende dun sa solution kung nasaan siya. Yeah? So, this is your conjugate acid and this is your conjugate base of water. Okay? So, ano ngayon yung equilibrium or Kb ng ammonia? Can you guys recite? We have
NH4
NH4
plus
NH
OH negative.
for positive.
times
OH negative.
OH negative.
Over NH3.
over concentration of ammonia. Ayan. So, tama. The Kb of ammonia is also equal to 1.8 times 10 raised to negative 5. Same sila ng Ka ng acetic acid. 1.8 times 10 raised to negative 5. Okay? So, yung general formula, nandito ba? The general formula for the expression of Kb is equal to conjugate acid times OH divided by your conjugate base. Ayan. So kapag meron kayong reaction, determine nyo kung sino yung conjugate acids and conjugate base. Kapag base yung nasa reactant, yun. Ito yung formula ng Kb. Okay? Tama ba? OH negative, Ca, Cb. Okay? So just like your Ka, Kb has no variation. So ganyan lang. Ganyan na talaga yung reaction ng Kb. Other than the actual formulas of the conjugate acids and base. So every acid has a Ka and its conjugate base so also corresponding Kb. The Ka and the Kb of the conjugate acid base pair are related by dKW, which is the ionization constant for water. So for conjugate acid base pair, KaKb is equal to Kw is equal to 1 times 10 raised to negative 1 times 10 raised to negative 14. So in addition, you can use the following shortcut, which is pKa plus pKb 14. So for example, the Kb for the acetate ion, so 'di ba, ito yung acetic acid natin. COOH plus water. We have H3O plus and then your acetate ion. Ayan. Not oras yan guys, baka alas 2 na. I-anandak 2 o'clock ka.
Yes, ma'am.
CH3COO negative plus water will form your acetic acid COOH plus OH minus. Kanya? So ano yung Kb ng acetate ion? Kb ng acetate is, we have your, so this is your conjugate base, conjugate acid. Yeah? So OH times conjugate acid divided by the conjugate base. So this is your OH, concentration of acetic acid, and then concentration of the acetate ion. So meron tayong Ka ng acetic acid which is 1.8 times 10 raised to negative 5. Ano naman yung value ng Kb ng acetic acid or acetate ion? So we use the Kw, which is equal to, so Kw is equal to Ka Kb. So anong formula ng Kb? We have Kw is equal to, or Kb is equal to Kw divided by Ka. So substitute natin yung values. Ano yung makukuha yung value? Ano yung na-compute nyo?
5.57. Ay,
5.56 times 10 negative 7.
Oh, ayan. Okay. So, ayan yung Kb ng acetate ion. So, also, that is also the Ka of your ammonia or ammonium ion. Kasi pareho ng so, Ka of acetic acid. K of the acetic acid is equal to the Kb of ammonia. So kung pareho, the Kb of acetate is also equal to the Ka of your ammonium ion. Okay? So ito, let's continue the example. Tapos tuloy natin sa Thursday yung discussion. Isaran lang natin to, tapos tuloy natin yung discussion. So kanina, nakuha natin yung 1 to 3. No? So, determine that the conjugate base of your formic acid is your formate. So, determine the equilibrium expression of your formate ion. So, HCO2H plus OH minus. So, Kb is, we have OH minus times divided by your, so ito yung conjugate base, conjugate acid. So we have HCO2 negative. So pag given lang kayo ng isang species, kung alam niyo na kung ano yung ano, kahit hindi na kayo magsulat ng reaction, no? Sulat yun na agad kung ano yung Kb and ano yung mga nasa species dito. Okay, as long as alam nyo kung sino, kung conjugate base ba yon or conjugate acid. So kapag gamay na nyo na, pag-determine ng CB and CA. So anong value ng KB? Meron tayong Ka kanina na 1.8 times 10 raised to negative 4. So KB natin is KW over Ka 1 times 10 raised to negative 14 divided by 1.8 times 10 raised to negative 4. Tama ba? At Kw tayo?
Five point 56. 5.56 times 10 raised to negative 8. Ayan, okay.
Okay. So, ayan. So, guys, masurutan nyo. 30 topics tayo in weeks in acids and bases. So, awantay pa iti pag-compute the acids, TPH the acids and bases. So, I hope naawatan nyo di discussion tayo para mas madali yung maintindihan yung pag-compute natin ng pH values ng weak acids and bases.